You could do your grocery shopping. That's what you said.
The country is quiet then.
Hey, Christy, good to see you.
Hello.
Hello.
I like your website, by the way.
Thank you.
And I sometimes got clients that needs design. I do not have any designer that I can send them to. Maybe I could use your reference and like tell them about you. So let's see if that works out for you.
Yeah, it would be great.
All right, guys. Hello. Are we all of us? Yeah.
Yeah.
I don't think we're waiting for anyone else. All right. Hopefully everybody is okay. The weather is not that good today. It's been raining for the most of the day in here. Right. Let's get into it. So today we're gonna be talking about making a CLI, which is command line interface, using Node.js. Well, before we get into that, so just so I'm up to speed, what do you know about CLI and Node.js in general? Don't be shy, please. So Thomas, nothing. Ricardo?
Yeah, I'm familiar with the overall scenario.
Okay. Matt?
Sorry, I know nothing.
You know nothing? Christina's?
I've heard about Node.js, about like Word, but I don't know about this. Nothing.
Okay, good. Well, good. So I know where to start. Right. So.
We need to do for Monday, is that right?
Sorry.
Sorry, maybe my connection is bad. No, I was asking if it's the project we need to do for next Monday. Is it CLI? That's what Vasily mentioned in the chat.
Yeah, I think you will have some kind of task to do, probably for Monday. I think that's what it is. Yeah. Right, but we will confirm on Slack later. So let's start from the very beginning then. I will just tell you quickly. So CLI, basically what it is what you see in here, right? So this is a console.
Are we supposed to see something?
I don't think you're sharing your screen.
Am I sharing my screen? Oh. Always. Here you go. And it's this one. Right, can you see now?
Yeah.
Yes.
Right. So, as I said, CLI and Node.js today. CLI is basically what you see in here. It's a command line interface. It's nothing to do with JavaScript. It's just generic term for command line rather than like a graphical interface. What I mean by that, sorry? No. What I mean by that is there are no windows, for example, in here. There are no buttons or anything like that. It is text command line, basically, text-based. That being said, people did some smart things every now and then. You can actually render a table. You can even render a picture if you spend some time doing ASCII codes and stuff like that. But anyway, it's just basically a text-based interface. That brings kind of some challenges and some advantages as well. The one advantage is that there is no rendering engine, for example. So you don't, all these buttons and everything else that you see on the website, that's being handled by rendering engines, and those are slow, right? So if you say, I want to have a page with crazy background with a gradient on it and 100 buttons and stuff like that, that engine needs to translate it and show it on the screen, and that takes a lot of time. While console is much faster because you don't have to do that. All it has to do is to just run your code. So there are some big advantages for that, obviously. The first thing that could come to your mind is servers. So, when you actually have some kind of system, if you look at some kind of web app or any kind of website, really, usually have the front end and the back end. So you have the front end, which is in the browser, and the back end, which is usually some kind of command line tool that is running on the server, because it's much faster, because it doesn't have to worry about the rendering and anything else. It's just basically processing data. That being said, you can still interact with the user, and your main interaction is your keyboard, right? That's your main input. You can have different inputs, but for our case, the main input is your keyboard. So whenever you think about a CLI application, you're thinking, what can I get from user via keyboard? And for example, if you think, well, another input could be a file, you can't really take a file and drop it in here in the console. You need to ask the user, where is the file? So the user would type in here, the file is in /user/Thomas/file /file txt, right? So anyway, the input would be just this string, and then you need to do something in your application. So that's what I mean by the main input is just your keyboard. So you're gonna be receiving whole lots of text from user, and you're gonna have to process it somehow. Now, that brings some challenges, right? Because a lot of time you will want to know if the argument that the user is actually giving, if the input is actually correct. So for example, if I ask you for a file and you say, you know, this, then how do you know it's an actual path to the file? So you would have to verify that somehow, and that's where it becomes a little bit harder. For even another example, if I ask you, and I think this is later in the slides, if I ask you how old you are and you would put 18, even though you know that you're putting number in there, for the program, it's still just a couple of characters. It doesn't know if you're actually putting a correct value in there. So you're gonna have to deal with that in your application. So that's mainly what we want to show you today, is that you take some kind of input from the user, you make sure that the input is correct, and then you can process it and basically output something else. So usually command line applications, they have input and output. Very simply, if I very simplify it. So input is from the user adds something, the output is whatever you show in the console. So for example, another command line application would be listing all the files in your directory. I'm not sure how familiar you are with console in general, but if I want to list all the files in my directory, I would write ls, and it will show you all the files, right? So ls is an input from the user. You're basically saying, I want to run this application, and this is the output from the application. Now, if I do lsla, which is just an argument for this application, this is already another user input. So you're saying, I want to run this application with this user input, and the output will change accordingly, right? So there's one application, it can handle different user inputs, and it will do some kind of output. If I write something that is incorrect, which I actually not sure if I
Sorry, what
just
this -la did actually? What does it do?
This is just an argument for this application. So internally, when you run this application, inside of it is just lines of code, right? And it will check what are the arguments that the user actually supplies. What are the arguments that the user wants to run this application with? And then internally, it will decide, okay, well, for L, I want to run something. I want to change the output somehow. For the A, I want to change the output somehow. Usually, you can do ls. I wonder if there is a help on this one. Sorry, I haven't used this for a while. But anyway, usually for command line applications, you have something like help, and it will print out all the different options that you can put in there. Can't remember what it is now.
This is an application that someone created.
Yes.
And kind of added all these like dash, like help or whatever,
yes.
And kind of programmed it, and now everyone can access that.
Yes.
Okay.
So every kind of command that you're using in your command line is basically standalone application. So for example, I have node in here. So if I write node, this is an application, and it can take some arguments as well. So if I say node-v, it knows that I want to print out version, right? So node is an application, and then it takes some kind of params, and it will basically behave depending on what params you give it.
And this is not done on JavaScript. It's on whatever language.
These applications are not done with JavaScript now. They are done with something different. But it doesn't really matter. I mean, if you create, so for example, if I do console log in here, right, I can still run it as a node index.js, and you can see I have to, basically this line has to be compiled into a computer script, right? And so it needs to be basically compiled, because right now it's just a script. Node, for example, is already pre-compiled. So when you install it, it's already pre-compiled. While our index.js is just a text, it's just a script. So it needs to be compiled somehow. That's why we have node in here, right? So we say node, run this script. So it will kind of compile it on the fly. And then when you run it, it will print out something. Now, is everything clear so far?
Yeah.
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 So now,
I don't understand why I use always node index.js. I was using it without really understanding it. But
yeah. So it's basically you saying this is the application I want to run, right? Which is, in this case, it's our compiler. And for Node knows that if, as a second param, if you give it a file name, it will look for it in the same location and it will try to compile it and run it. Okay. So that's how Node does it. So now going a little bit specific in the Node, whenever you run a script in Node, it will give you an object with some kind of values. So the object is process. Okay. This is basically what your computer is running. So this is the access to the process that is running right now, your script. So in this process, there's a whole bunch of useful stuff. If I log it out, it's going to be huge probably. See, so there's a whole bunch of stuff that will tell you basically some information about the computer. It will tell you, you know, the configuration of your compiler and all sorts of other stuff. You don't really need to know all this, but you know, some of it is interesting. So for example, PID, which is process ID, that means your script is running in this process ID. So that's an ID for the computer to know your process, right? So for example, last time we talked about while loops. For example, if you create a program that has an infinite while loop, so basically eating your memory and everything, and you can't kill it, I mean, you can't exit it because there is just no exit from the program, you would find its PID and you would kill it manually through the system, right? So like for example, this is important. Now, the one thing that I want to show you right now, the important one, would be the argument. So the easiest way to have your script accept arguments would be through process.args. And this basically gives you the arguments that you give the process to, including the process, the script itself. So if we run now index.js hello, it will give you this, right? So now you're getting the arguments that were given to the process. Yeah. So you see you have this is my compiler, this is my node. Okay. This is the script that I'm running, and then this is my argument that I'm actually giving to the script. Okay. So you can get these kind of information from the script, from the process. So it's very useful. There will be more. So for example, environment variables. I'm not sure if anybody.
So can you explain again what process? Yeah. If the process is actually everything, all the information that is related to nodes and your computer.
Yeah. So inside of the process, you have all the information that are related to that to the run of your script, right? So when you run the script, it will collect some kind of information from your computer in that moment, and you will have that available. Okay, so you can kind of, the idea behind it is that inside of your script, you will know everything about the computer, and everything about the run of the process, so you can decide what to do, right? So for example, as I showed you now with the arguments, if we wouldn't have the process object, then the script couldn't access those arguments and it couldn't decide what to do, right? The same way, you could say, another example could be, I want to decide what to do based on the client. So do I run a Linux machine or do I run a Mac OS machine, for example? So in the process, there will be somewhere this information. Somewhere here will be the client string, basically the client identification, and it will tell you I'm running on Linux or I'm running on Mac OS. So for example, why would that be useful? If you want to give somebody a hint how to do like a key shortcut, then you could do console log to copy, for example, to copy press, and then in here you could decide, right? This is gonna be like a pseudocode, but you could decide.
You can switch depending on what machine he has.
Exactly. So you can say process client equals Linux. No, actually, let's do it here. So const is Mac OS, and then you'd say process client equals.
Yeah, and when you look at all the processes, you can actually go and have a look at all the options.
Yeah, so you can, I mean, you can log it out and you can have a look at it, but there's a lot of it in there, so you don't really have to, do that. But you can see, for example, you can have the architecture, so if it's 64-bit or 32-bit. You have the platform. There's other stuff in here.
Wow.
That would be useful, but it depends on your application to actually decide what you need from there. So this is not there. I'm just making this up, but just to show you. So to copy press, and then on Mac OS you would say press what is it, command, and if it's on different client it's control, right? Yeah. So you would have something like this, and then when you run it.
Oh no, that's quite elegant to have like the way you write it with question mark and then yes, no. I didn't know this.
Yeah, this is ternary. I'm not sure if you have done it yet. It's kind of if statement in one line. They are very useful. Yeah. So you can see, like, because the client is not there, so it basically evaluated to false. So now it says to copy press Control C, right? Because it thinks that I'm not on Mac OS, right? So that's the kind of usefulness of this process object, because it gives you a whole lot of information about the run and the computer that you can actually use to decide stuff in your script. If it wouldn't be for this, then every script would be dummy. Basically, it would do the same thing all the time, right? Because there would be no inputs. So that's the process in Node.js.
Okay, got it. Thank you.
Does everybody understand? Cool. All right, let's have a look at the slides then. I'm gonna be sorry.
The question that I have is how you actually got to the command line, like your terminal screen in there.
Yeah, this is just terminal. This is nothing. It might look a little bit strange because I have this special terminal, but it's just a terminal, like you have on your computer.
So what we'll do basically just go to the terminal, write node space the name of the script, and that's it.
Yes.
Okay.
And if you can even do without .js, because Node will know to look for .js in the in the same location, but that doesn't really matter.
Do we have any way to do data entry in a script running in the terminal? Like, for example, if my index.js is like console log, enter your name, then I will have something like let name equals that input, like in any other programming language, or we do not have access to actually do data entry in the terminal for
Yes, so you have two ways to do that. One would be to do it beforehand, right? So you could say, actually, I would do node index.js, and then I would say Thomas, right? So that's one way to kind of
that's getting it as a parameter, but not once application is running.
Yeah, so this is the one way. doing it during the run of the application, you can do it as well. But there are different ways to do that. To do it by yourself would be more challenging, and that's why we use third-party stuff, third-party libraries, basically. So they will kind of let you, because as you know, everything is kind of synchronous, right? So if I write a bunch of lines of code in here, everything will run from line 1 to line 9, and that's it. So it's not going to wait for user input. So if you want to kind of stop the application to wait for user input, you need to do it somehow, and usually you do that by either creating a new thread or spawning a new process or something like that. So there are different ways to do it. If you want to do it yourself, that's fine, but it's kind of out of scope of this, of kind of like an introduction. It's better to just use like a third-party library. I say better, but it's not always better. But in this case, it's better because you don't need to know exactly all the bunch of code that you need to do, because there is it's quite complex to actually read something from the terminal during the run. But we will actually do that. It was a good question. We will do that a little bit later. That we will be running reading something from the keyboard during the run, but we're going to be using third-party service. So yes, it's possible. Right. So let's go to the next one here. You will find that I'm going to be kind of derailing from the slides a little bit, because I think like I need to give you a little bit more introduction about the whole Node and everything. Actually, speaking of that, do you kind of understand what is Node comparing to like a normal, well, I say normal JS, but compared to like a JavaScript in the web page? Do you have any idea what is the difference? Right, so first things first, Node.js is not a programming language. Okay, that's the one thing to understand. The programming language in this case is JavaScript. Right, so the JavaScript that you use in Node.js and in the website and any other compiler is the same set, so is the programming language. Node.js is a, well, framework or library. People will tell you different opinions. It's either framework or library for JavaScript. So it's basically built on top of JavaScript to help you do stuff. What it does, it will expose different APIs, well, something that we call APIs. So for example, if you want to open a file, it will give you a file API. If you want to read something from user's keyboard, it will give you API for that. If you want to make a network request, it will give you API for that. So it's kind of, yeah, for me it's a framework. It's kind of it's like a collection of tools, APIs to kind of help you developing something. Otherwise you would have just clean slate and it would be very, very complicated. So that's Node.js. What you have in the browser is something similar, but they have their own APIs. And this is the kind of confusing bit, right? So what you can do in the browser with JavaScript, you cannot do necessarily with Node.js in the command line, and vice versa. So for example, with Node.js, I can now go and I can read any file on my computer if I have the permissions. Okay, so if I go now and I go to this folder and I say I want to actually read this file, this index. I want to actually read this file, then I can do that with Node script. I can actually go from the file system, open the file and read it. You cannot do that on the website because browsers just do not permit you to actually access files on your computer. Okay, so that's, for example, one difference. So browser and Node.js, even though they're both using JavaScript, they are different set of APIs, and you are limited to different things what you can do with them. Okay. The reason for that is that they are on different levels, what we call like high or low level. So let me just find something very sophisticated somewhere. Let me just see if I can get a browser up here. Sorry, this is not necessarily related, but I just want you to understand it before we move on. So, very sophisticated. imagine that you have your this is your computer, right? Here is your CPU. Here is your memory, for example. Yeah. Now, this is the lowest level you can get, okay, on a computer. They go a little bit higher. You have your whatever is attached to your computer. So network card, mouse, sound like speakers and stuff like that. You have all these things in here, okay. Now above that you have operation system, right? So you have Mac OS, Windows, all that kind of stuff, okay. And on top of that you have applications. Again, thousands and thousands of little applications. One of these applications would be browser, right? Now, if you're using browser, which is one of these applications, then you would have permission to access anything on this particular application, right? So whatever the browser lets you access, you can access, okay? But it doesn't let you to access other applications, and it doesn't let you to access anything below that, because this is the highest level where you can get with the browser. Okay, now Node.js is on the same level as these ones. So your script is running basically on the same level in here. So you're basically creating the same application like browser. I mean, on the same level, right? And that means that you have the control over what do you permit to access. So literally, you can go anywhere from here all the way here. Any layer in this you can access. Okay, so command line applications are much more powerful because you are the one who is deciding what they access. You can access files. You can access speakers. You can say, I want to go to the speaker and make it do something. You can access other applications. So you can, for example, there is one application running in here. You can actually get the ID of this application and try to kill it, for example. There's infinite number of what you can do. But that's the main difference between JavaScript. It's the same JavaScript. Like under the hood is the same JavaScript. It's just that there is one engine running in here in the browser and one engine running in the node, and they have different kind of permissions. The engine running in the browser will not permit you to do anything else than what it wants you to do, while with Node you can do whatever you want basically. Okay, and if Node doesn't have API to do something, for example, if you want to do something very, very specific with CPU and the Node just doesn't know how to do it, it will let you to basically run a new program that knows how to do it in different programming language, for example. So you can literally do absolutely anything in there. Okay?
Is this due to the fact that Node is run on the terminal?
Yeah, it's running basically on a lower level, right? So I didn't really put it in here, but this is your
whatever I guess framework you have running in that lower function will have the same access as Node.
Yes.
Okay.
So you see this green one, this green. Sorry, I really didn't have time to prepare better diagrams for this, but this green rectangle, like to be rectangle in here, that is your JavaScript running in the website, right? And this is the context that it's in, and it cannot go outside of it. It just can't go outside of it. It cannot access anything of this because it's there, right? While Node is standalone in here, and the context for the whole node is basically this whole thing is your computer, right? So Node is running in the context of your computer. Now, again, this is very simplified, but this is basically what it's doing. Okay.
Very good, thank you.
So, yeah, so that's just kind of important to understand when you run into things where you might think, okay, I have this website, and I know that in JavaScript I can access a file from the computer and read it. You can't, because website won't let you do it. You can do it only from command line, from something that's on the lower level. And that's why we have the backends that I was talking about earlier. Because if you can't do it from the website, then you will need to have your server-side application, which is the command line application, and you will need to communicate with that application to do things for you that you cannot normally do in the website. Okay?
Were you using the drawing program from Windows in that screenshot?
It was actually online. Yeah, somebody recreated it online.
Okay.
I have Mac, so I don't have the paint.
Yeah, I was wondering if you were doing some sort of virtual machine thing in there. Just curious.
Right. So to move on with this, right. So we have some to use CLIs. There are a couple of kind of concepts to understand. One is libraries. As I said, those are third-party pieces of software or pieces of scripts that people will write for you, so you can use them. For Node.js, there's a basically manager for all these packages that they call them packages in Node.js. It's called npm, and this is a registry of all possible packages that you can install into your command line applications. Okay, there's many millions of them, and you can search for anything in here. So if you want to do something in your CLI, you can search for package and it will let you do it, right? So these are the third-party libraries or packages, whatever you want to call it. I lost my. Here it is.
And Thomas, just
yes.
to put things in context for a noob like me, what is this achieving? Like, where would you use that
So
online interface? Like, you have like a simple example of a website. Do you need to do that when you kind of work on a website or?
So you would use like a command line script or command line interface. You would use it when you don't need the graphical interface, right? So basically, you would use it anytime you can if you don't need the GUI, so the graphical user interface, because they are faster.
How you say the front end and back end. So it would be used for the back end.
Yes. Yes.
Okay, got it.
Yeah.
Cool, thank you.
No worries. So you have libraries that you can install. Libraries are basically abstractions. They make your life easier, right? So as we talked about with the user input, because writing your own user input would be quite complex. So you find a library to do it for you, and you install it, and you can just use it out of the box, and you don't have to worry about it. So they are basically kind of abstractions built on the basic script that you can install to your application. They are very useful. My advice is don't overuse them as well, because you don't want to see a simple project with like 100 libraries installed on it. Like it's better to kind of try and do it yourself first. The kind of logic that I like is that if you're using a library, you should be able to recreate it yourself. Otherwise, you don't really know what you're doing, right? So if you say, I'm using this library for this purpose, which is perfectly fine, you should still understand how it works, at least roughly how it works and how would you write it. Otherwise, you're kind of using something that you don't really know how it behaves. So that's kind of, I think that's quite an important point, because otherwise, you don't know what the consequences of things are with the libraries that you use. The second concept would be user input. So again, however the user interacts with your command line application, be it arguments or during run inputs. And structure names. This is basically how you write your code. This is kind of generic, not just for command line applications, but basically make sure that your code is structured and well readable and everything. Right, libraries. As I said, someone else's code. There is a library for everything. Literally, if you think about writing a piece of code, there is definitely already 20 libraries at least written for it. Documentation. One great thing about libraries, most of them at least, is that they have some kind of documentation. So, for example, if I look at the one that I had in here, and it's not here anymore. Let me just bring it up again. So if I look at any run, oh come on, right? I can't.
Can you use like part of a library? Because you mentioned you need to kind of master or know what's in the library, but can you then, if there are only just a few things you want to use from it, but not the whole thing, can you just?
You can. Well, some libraries. That's a good question. You can use some part of libraries, but usually you install the whole library and you just import from the library whatever you want, but you're still installing the whole library. Now, in the old days, that was basically it. So you import the library, and that library is going to be compiled into your code. So for example, your application is 1 megabyte, and you install 2 megabyte library, your application will be 3 megabytes, right?
Yeah.
Nowadays, with Node.js, they actually improved it, and now there is something called tree shaking. So basically what it does is, when it compiles the application, it goes through the libraries that you use, and it tries to analyze it and sees what pieces of the library you're using. And if it finds pieces that you don't use, and it's 100% sure that you don't use it, it will get rid of them, right? So nowadays, that's how it behaves. But there are some downsides, some upsides. I mean, it doesn't work always as intended, and you need to write. You and the library creator needs to write the code in a specific way for it to work. So it's not 100%, but it does help a lot. Like from a couple of years ago, it did help a lot basically. So let's just have a look at here for. Yeah, so for example, there is some kind of library, not iStack, right? Whatever that is, doesn't matter. If you look at it, it will, like, all this page is already documentation for it. So it tells you how to install it, how to use it, what are the different ways to use it, and all this kind of stuff. So this is one good thing about libraries, is that when you're using some library, it will usually give you documentation. So if something goes wrong, you can go back and you can see their documentation. Some of them are, like this one has very detailed documentation. You can see all the possible arguments that you can pass into it, what are the defaults and description and stuff like that. So that's one kind of advantage from using library rather than writing it yourself, because you have this documentation. If you write a piece of code yourself, you will kind of forget what it can do, basically, if you don't do your own documentation, which normally people don't do. So that's one good thing, because you have this kind of documentation. There's more advantages from using other libraries, but documentation is definitely one of them. Libraries generally, the term library and all these terms that you see in here, like modules, packages, gems, and dependencies, and all this stuff, these terms are used, basically everybody uses them as they wish. There is nothing set in stone. Same what I told you with Node.js, that somebody says it's a framework, somebody says it's a library. Once you get into more of a web development, you will start using React, for example. Again, somebody says it's a framework, somebody says it is a library. There are just different names for the same thing, basically. There are some kind of, some people try to put together guidelines what to call what, but there's always a little bit of a blurry line, and people just can't agree. So whenever you see modules, packages, gems, libs, dependencies, any of that, you kind of know, okay, this is something third party. Gems, I would just point out, gems is a very specific for Ruby. This is different programming language, Ruby. You will never see that in JavaScript, but you will see modules, packages, and libraries. Right. Libraries npm. I showed you the website. That's the Node Package Manager. Well, it's short for Node Package Manager. You can install packages, and it will be in Node modules folder. Let me just go to the codes. What does that mean is, when you installed Node, the npm, which is another application, will be installed together with it. And it's the Node package manager, and that will let you to install packages, uninstall packages, and list them and all this kind of stuff. It's very useful, obviously, because otherwise you would have to unzip it and I don't know whatnot. This is just another command line application. So I will show you how it works in here. Right. So you can see that I have Node already installed. You should probably have as well. I have this version of Node, doesn't really matter. And with it was npm installed. So again, what I showed you before, if you don't give the npm any argument, it will just give you how to use it. It doesn't do anything, it will just give you kind of help how to use it. So npm is a Node package manager, and this is all the stuff that you can do with it. Obviously, we're not going to go through all of them now, but this is all the stuff you can do with it. In a Node project, let me just open this as well. So you can see we have now index.js. I want to make it into a Node, like a proper Node project. So I would say npm init, which means initialize this project. And it will ask you a bunch of questions. And it will, at the end of it, I'm just gonna go through it. We don't need to concentrate on this right now. Once we go through it, it will create a new file. It will create a new file, package.json. Now, package.json is like a very important file for Node.js applications. It has everything about the application in here. So it knows what the name is, it knows what the version is, and so on. And as well, it knows what packages this application needs to run. Okay. This file is important because when you give your application to someone or something, it will look at this file and it will get all the information that it needs about the application from here. Okay. So for example, if you say, I will take my application, give it to different computer. The computer would go to this file and look at all this information, so it knows what it needs to run, basically, and know all the information about it. So going back to npm, if we install now one package, so we do install, and we can just say colors, for example. And I do save. So what this save means, this another argument for the npm, and what it means is I want to save it into my package.json. So in the future we know that this package, this application relies on that library. So let's just go through it. This is npm is a command line application, right? That's what we're talking about. Install is first argument. It's telling the npm that I want to install a package. The second argument is colors, which is the name of the package that I want to install. And the third argument is save, which means I want to save it into package.json. Inside of the npm, just out of curiosity, right? Inside of the npm, if this would be npm, it will take all the arguments. So it would do something like this. This is going to be another pseudocode, but it would take all the arguments. It would do slice2 because it removes, so the slice2 means it removes the name of the script and the location. So it would take all the arguments and it would analyze them. It would say if argument 0 equals install, then install a package. And then it could do else if arguments 0 equals uninstall package. Okay, so this is what's kind of happening behind the scenes inside of the npm. So it will take all the arguments that you give it. It will have some kind of internal handling of them, and it will decide what to do. Okay, so this is exactly how command line application works. What npm does when you say it should install something, it will literally go to its server, so pretty much to its website, which I had somewhere in here before. Again, it will go to its website here, not here, here, and it will go, so it will search for colors, it will find package colors, exact match, and it will download it basically, right? So all the packages are stored on this npm, and it will just download it from here and install it on, and basically unzip it on your computer. So it does the kind of hard work for you, where you don't have to go and install it every time. And this is especially useful when you have different versions of the packages. So if I install it now, you will see that it's kind of going through the process, blah blah blah, and then it will install. It will select the latest version, and it will add it to your application. So now if you look back at package.json, you will see a new thing in here, which is dependencies. So it will tell you, okay, here are all the third-party pieces of scripts that I want to run with this application. And one is colors, that's the one that we just installed, and the version that we want to use. Okay, and also you will see a new folder in here in your file system, which is the node modules, and this is where it extracts all the scripts that you want to install. Okay, so package.json and node modules you will see in every Node.js application, because pretty much every application has some kind of dependency. So these are the most important parts of it.
So basically, when we do npm install and then npm test, which is what we do for all of our we are basically downloading the whole package.
Sorry, you were cutting off there. Can you repeat that?
Oh, sorry. No, I was just saying, like, when we do npm install on our machines, we actually install the whole package, the whole thing, including colors.
Yes. So exactly. So if you look at, if I add something more in here, so I do, for example, classes, so classes, and then I am pretty sure that you're using jest or something like that for the test. So if I do jest, right? So I install a bunch of packages, and you will see that in this file you see the package.json, how it's updating. So now I have classes and colors. So this application depends on these packages basically. Once this this was a big one, I should have installed it one. Once you install it, I just got it. So once this is installed, I will revert the application to its initial state, as you would normally. Like, if, for example, if you ask me, wow, this application is cool, can you send it to me? I would not send you all the packages I download, because it's huge. I would just send you the package.json and the script, right? And which is much smaller. So we can actually have a look at the size as well. Okay, so now we have 3 packages. You can see it's in our dependencies. Now if I go to my file explorer, and I go to, where is it, projects, come on. So I package this up. So, oh, so you can already see, oh, you can't see here. Here. You can see that this has 12 megabytes, right? So if you ask me, give me your application, I would give you 12 megabytes if I just give you everything. Okay, but or I can delete the node modules, because that's basically the third-party libraries that we use. So if I delete this and I just package these, then it's 47 kilobytes. It's much, much, much smaller, right? So if I just give you these 3 files, which one is your script, one is the package.json that has all the information that it needs for the application to run, and the last one is package log, which basically means it logs the versions of the application, so you can't install other versions. So it kind of gets rid of the like different version problems when you install it on different computers. So if I just give you these, this is what you would receive, these 3 files. Okay? That's what you do now basically with your exercises. And then you clone it or install it somehow on your computer, and then all you have to do is npm install. And it will go through the package JSON, find the dependencies object, and it will take one by one and install them on your computer. So you get your fresh dependencies. There are some of them compiled specifically for your computer, and it's much smaller to kind of share the application. So that's the whole point of this. Any kind of scripting language doesn't need to be JavaScript. Any kind of language where you have these kind of dependencies or packages will work on a very similar concept. So you would have one file that is like a definition of your application, which will have all the dependencies in there. And once you install it on a new computer, it will fetch the dependencies from internet, basically from their website. So that's how the libraries work. Let's see what else is in here. Does it make sense?
Yeah.
Yeah, Mark?
You're just looking at the exercises, and the dev dependencies are just concat and jest.
Yeah. Well, right.
Calling the whole module all the time.
Yeah, every time we take it from GitHub.
Mm-hmm. The one thing that I should mention, I mean, this is a little bit, you don't really need to know right now, but what you can do also is you can do save def, and that will save the package into def dependencies. The main difference between dependencies and def dependencies is if you actually want to share your package as a library. So I can now take my index, I can now take this and say, well, this is actually a library that other people can install, right? In that case, if I'm actually maintaining the library, if I'm actually changing the library somehow, I would install all the dependencies. I would install my dependencies, which everybody needs, and I will install my def dependencies, which only I need if I work on it. But then if other person says, well, this library is really useful, I want to use it in my project, they would install only dependencies. They wouldn't install def dependencies because they're not actually maintaining the library. They're not actually working on the library. They're just using it. Okay, so there are the two kind of different dependencies. Usually, you would find def dependencies to be something like jest, something just for testing, or anything like that. So they are literally just for the maintainers of the library, what they need to actually develop that library. But for you, as a consumer of the library, this is the most important one, because without these, it wouldn't run properly. But without these, it would run properly, basically. But that's just kind of side note. Yeah.
Just to add something, Thomas, a good example of this is what we are currently doing in the class, because when we run the test, when Vasil or whoever coded the actual applications, they are using some testing modules from existing already. So they're doing some sort of unit testing or something. So they are actually putting that in the code that they are providing us. So we are users of something similar to this without knowing it. We just run it and it runs. So as a user, we've been using this already in coding.
Yes, exactly. So again, like what you will find, I mean, if you actually want to and you go through node modules, look at this, right? So this is all the dependencies for your script are in the node modules. Okay. If you open that, look at my dependencies in here. I have 3 dependencies only 3 dependencies. If I actually open node modules, look at all this. These are all the third-party libraries that have been installed to this project, right? And the reason for that is, if you look at Jest, for example, you will find package JSON. Every single node library or project or anything like that has package JSON, right? So if you look at package JSON, look at their dependencies, right? So they have another 3 dependencies. right? So, and these 3 dependencies, they will have more dependencies. So that's why when you install one library, it doesn't necessarily mean you're installing just one library. Basically, that library can have its own child dependencies, what we call it. So you will find that even installing just one library, you might actually install 50 of them, right? So yeah, so as Ricardo said, like you might be using something, but kind of on the background without you actually knowing it. It might be using 20 other libraries. It's just yeah, it's just that's how it works.
And to add more to what Thomas says at the beginning, you are supposed to know the code behind the libraries you're using, because very frequently you find out that a programmer just gives you a code, then he's using whatever dependencies you have no clue about. All of a sudden, for whatever updates, the dependencies are no longer working. You get back to him like, hey, this is not working. And he's like, I have no idea how to fix it because I was using somebody else's library and I don't know what the library does or how it works, and then I cannot fix what I told to you already.
Yes, you will get, I mean, as you get into more complex libraries, you will find out that if you file an issue with a library, they might tell you, this is actually not our issue, this is issue different library that we are using, as Ricardo said, which is a bit annoying, but it also kind of shows, when you're choosing your library, what to use in your own application, you need to be careful sometimes as well, because not necessarily the first result is the best result, right? So sometimes you will want to see what are actually the dependencies of that library, because you might find that somebody publishes library, it might be very popular, but on the background it's using 50 other libraries, and that's never very good, right? Sometimes you can't avoid it, but most of the time it can tell you something about the actual library. And the one thing that to think about as well is, at any point, one of those libraries could just basically break, and then the whole application breaks, right? It just kind of populates through the chain up. So yeah, it's just something to be careful about as well, and it increases the size. So there's one really cool project which I will show you for libraries, and I think everybody should be using. It's called Bundleophobia. Bundleophobia, I think it's called. Bundlephobia, actually. Okay. So this is just a website that somebody developed, and you can put any package, any npm package that you want in here. Oh no, it doesn't matter. Any npm package, it will analyze the package and it will show you all its dependencies. What is it made of, right? So you know that if you're using this package, this is the latest version. This is how big it is going to be. Not necessarily how much is going to increase your application by, but this is how big the library is, and this is everything that is consisting of. So you know that this is not actually just one library. This is collection of multiple libraries, right? So this is a very cool thing to have, because otherwise you wouldn't know, basically. What I told you about. So if you have a look at this, I think. Yeah, so if you look at down here, you see it says tree shakeable. So this library has been written in a way that you can actually shake it. So if you use just 2 functions out of that library, it will remove the rest and it will make your application smaller. And look at this, right? So this library, Moment, has no dependencies. It's been written from ground up without any dependencies. So if you want to use a library, for Moment is to do with date manipulations and stuff. If you want to use that, like that kind of library, then Moment would be probably pretty good choice, because it's been, it's 100% maintained by the creators, and all that stuff. So, and it's tree shakeable. So this, you need to kind of think about a little bit what you're putting into your software, especially if you're thinking about releasing it somewhere or anything like that. There are. We're going too deep into this, but there are other considerations, because you might find, and this is from my personal experience, you might find that you use a library, and then, for example, I was working on a banking system, and then you put it towards you put it in the bank, and the bank will analyze it, and it will say, well, this library has a dependency of this, and that has a dependency of this, and this is known as security issue, and you can't really release it without that. And then you need to go back and rewrite half of your application because you used that one dependency and you didn't analyze it properly. So it can have a big consequences. So but obviously for our use case that's way ahead. Right, let's keep going through the slides because we're getting a little bit behind. So what do you do with libraries? You install them, then you you step 1 install them, step 2 you actually require them inside of your application. So that basically means you import them into your application and they are ready for you to use whatever the API of the library is. You will hear me saying API a lot. The API basically means the kind of interface that the library gives you. So it can have multiple functions or multiple values or something like that you can access through a library. So that's generally called API or interface. And then you can see that it will be saved in the node modules. So I think we need to install the whatever it's pronounced, clue. Let me just do that. And if you want to remove dependencies from your package, it's as easy as literally just deleting these. You don't need to uninstall it manually or anything like that, because eventually you will basically purge your project and start it again, and then it's not going to be installed.
What's the difference between just doing npm install and then the module and then --save, or not having that --save? What's the difference?
Yeah, I mean it's a good question. I don't actually know 100% because it's been, I think it's a year or something like that since it changed, and now it seems to be saving them automatically into package. I don't know why. I honestly don't know why. I didn't look into that. But yeah, you like, as I know it, you should be writing save. But I think it might be some kind of npm config that you can turn on or off that automatically saves it. I'm not 100% sure.
Got it.
Yeah, so you have clear, and then yes, so I see. So it's supposed to be like color clear, and this is basically a library. So let's have a look at the documentation, because we installed something without actually reading what it is. Right, so if you open it in npm, you can see that Claire is the fastest Node.js library for formatting terminal text with ANSI colors. So it basically will let you print out, it's like a console log on steroids. It will let you print out stuff in the console with all sorts of formatting. So you can make the text different colors, underlined, and all sorts of stuff. Again, you can read all the documentation. This is very useful, right? So they have all this documentation, how to use it, what kind of. So when I say API, you see like it has dot enabled, it has this dot red, dot italic, dot yellow, and all this stuff. So that's basically the API of the library.
And this is a good example that Thomas was asking before about CLI. This is a good example of a tool that you will use for developing something that is never going to the browser. Like it's to make it look better in the server side.
Yes, I mean it depends on application. Usually you will want to add a little bit of style. Yeah, I mean you saw me installing colors library before. That's what we used to use a lot, just to kind of like differentiate between logs and stuff like that. I'm not sure about all like going too crazy with the formats, but usually different colors of text at least are quite useful in the like you see in here. Like it makes it a little bit easier to read in the application. So let's go through the documentation. We can install it, and then we can just create some kind of red text in our application. So if we go back to the code, which is here. and do. So first you need to require it. So you would say clear require. Now, I'm not sure if you have done already something in Node.js, but require basically means I want specific package or specific file inside of the application. Okay, if you just use this name like that, the first thing it will do, it will go into Node modules and look for if this module actually exists in there. If it does, it will require. If it will import that. You can also do. You can also import index.js, for example. So you could say, import. Require index.js, and it will just basically get the text from index.js. But as you write the library in here, it will go first to Node modules, and it will check if you actually have it in there. And then we can say clear red hello world. So this should give us.
So that module clear is actually not implicitly embedded, although you installed it. So you need to still declare it in your index.js file.
Yes, you need. So it's installed in your project, but it's not imported in there. You need to. And the reason behind it is you need to import it. And the reason behind it is that you might import it only in some specific places of the application. You might not want to import it every single time in every file. So you just need to manually basically import it. I'm sure that there will be another library that you can use that will just import all the packages. I'm sure there will be something like that. But usually you do that because it just makes the file. Makes the project a little bit cleaner. Let me just see what are we doing here. Oh, what? Maybe I'm doing something wrong. Going to console log. Sorry, I didn't use this library before. Yeah, there you go. Right. So the way that this works apparently is that this will actually format the text. It will return the text that you want to log out, and then you need to put it in the console log. So it doesn't log itself. It just gives you the formatted text, so you can manipulate it later, I suppose. You can chain it as well. So from what I see from the documentation, so if you look at the documentation again, you can do chains. So you can say it's blue and bold and underline. This is just whatever the library decided to do, basically. So if I do red and underline, then you see it's red and underline in here. Actually, let me just put this in here. Right. Okay, so is it kind of clear how to use libraries, how to install them and import them into your project and use them?
Yeah.
Yeah. I haven't heard anything from Christina yet.
I'm thinking about Node. This is backend, am I right? Or Node.js, it's not backend.
Well, in a sense, it kind of is a backend, but you can just do. Node.js doesn't necessarily need to be in a website context. Node.js is basically just a compiler for JavaScript, and we can create an application and then share it, and it has nothing to do with website. It's just an application that you can run on computer. So it is. You could call it backend, but that would be more in a context of website rather than just generally Node.
And when we use Node.js, what client can see on the website?
Well, yes, go on.
So, for example, I use Node.js with library and etc. And what client can see on the in browser? What? what they can see on the website, for example.
So the way it works, client can't see anything about your node process, right? So your node application that is basically feeding data to the website, it will not disclose any information about that to the website, which is not entirely true, but that's how it works. So basically, if you make a request to a node backend on the website, you will get some data back, but you will not know anything about the node application. You don't know what happened in there or anything like that. You will just know what the node tells you back. So as we do, so this is our output. Currently, in our node application that we have in here, this is our output, which basically means writing something in the console. But that doesn't necessarily have to be always the output. Other type of output would be a response to a website, right? So when the website, the front end, asks something to the backend, the output in that case is not something in the console. It's whatever you give back to the website. Okay, and what do you give back to the website? So if you say, you know, I mean, this is just not code, but if I say just website reply hello. So if you do something like that, then on the website, all it would get is this hello. As a matter of fact, it wouldn't actually know that it was node process that generated this response, right? It would just know that there is some kind of backend. So it doesn't know anything about your dependencies or anything about, you know, what server it runs on or anything like that, if that makes any sense.
Okay. Yeah.
You can tell it. So if I say website reply hello and then I give it the process object, you can pass the process object back to the website and then it knows everything about the server, right? So it really is up to you as a developer. What do you decide that the website should know about, what it needs to know?
Okay, thank you.
Yeah.
You would use that, for example, if you were, I don't know, like getting info from like an API and you get data, then you can kind of convert the data and put that into your backend and then have some kind of command to actually put it on your website or something.
Yeah, you would. I mean, you would use that. I mean, that's backend, right? So you would make a request from the website to the backend. It would do some kind of work and give you response back. If it would be giving you, I mean, the scenario where it would be giving you back the actual details about the process or the server that it's running on, it doesn't happen that often. Those things would be more useful for like a dashboard of, like, if you have a website that is a dashboard for that actual server that is running on, then you would probably pass the information back, but not necessarily for like a normal website. The normal website doesn't really need to know about the backend anything. The backend could be absolutely anything. It doesn't have to be node application. It doesn't have to be on the server. It can be in the cloud. It can be anything really. Okay. Right. So we have a package in our application. We are using it. What else do we have here? This slide should be edited. The bad documentation is difficult to read. Not every documentation is difficult to read. There are some documentations that are very easy to read, but in generally, having a good documentation for library is quite difficult, and it's a lot of work, but it's very useful. This is very true though. Reading documentation is a valuable skill. You will find that as you go, if you now go from this course and you start applying for jobs, you will find that reading documentation will be one of the skills that everybody will be asking for. Because honestly, no matter how long you coding, that's what you do a lot of time, right? So you can't avoid using libraries. You can't avoid using third-party APIs or anything like that. You will have to use them at some point. And what you need to do is to read their documentation. And by reading the documentation, I don't mean one page on Npm. I mean a lot of stuff. Like there are whole websites that are documentations for some projects, and you need to go through them, and you need to know how to orientate through them to actually find the information that you need. And you will get better at it as you go. The one thing I would say is always read the documentation and be very patient. So if you in the future, if you encounter some kind of issue with library or with third-party service or anything, always read the documentation basically even before you ask people for help or anything like that. Always read the documentation. It's not the greatest example, but your manuals, any kind of appliance at home that you buy or anything like that, that's basically your documentation. So if you have a coffee machine that suddenly starts blinking, red or something like that, instead of actually calling their support, first thing you should do is open the manual and see what it means, right? They have the documentation there. You will find that, if it blinks 3 times red, it means something. So this is exactly the same thing for libraries and services on the web. There are some examples in here. Let's open it. Oh, this is the one for Claro. That's the one that we were looking at. So, for example, you see this library has this kind of documentation. So it will show you everything that you can do with it, and so on. You will see that there are some links to go further from the documentation as well. So, for example, if you want to see anything about conditional call support, then you need to come in here, and you will see what else can you do. For example, if you want to, if you're using this library and the colors are not appearing in the terminal, you might wonder why. So you kind of go through the documentation, and you need to find out why couldn't it be appearing, and then you have this thing in here that will explain that in the colors will be disabled in TTY contexts, which is different kind of terminal. So you need to you need to be able to read this documentation to find these little notices and important clauses and stuff like that to actually debug your application and why it doesn't work. I cannot stress enough that you will be doing this a lot. But it is just a normal part of our job, basically, reading documentations. Right. Let me go back to this. We already did install the Clore. Let's install Lodash, which is another package. Lodash is a oh, hello.
Nola wants to learn coding.
Good. They should start young, really. I would bring mine, but she's currently screaming somewhere downstairs, so it's going to be bad.
She was screaming, so I had to take him so that my son can actually sleep. So.
Right, so we installed Lodash. Lodash is just basically a collection of helper functions to help you with everyday tasks. And let's see what else we're going to be doing. Right, any questions? So we learned what packages are, how to install them, and how to use them inside of your application. Any questions about that?
Nope.
I know it's a lot of information, and I probably gave you more information than was intended, but I think that if you understand the kind of underlying, what Node is and how it works and stuff, it's going to be easier for you to understand in the future the more advanced stuff that will come in. So if you have any questions, please ask.
Thomas,
Yes.
Node.js, package JSON. This is this library for Node.js?
Package JSON is a specific file in every Node project that has all the information about that particular project. So, wherever you deploy it or whatever script is using it or trying to read it, it will know all the information. So, for example, you will find what happens quite a lot is that once you create your application, you will want to put it on GitHub, for example. I'm pretty sure you guys are using GitHub with Vasil for the project. So you will want to put your own application in there. And then you will learn that actually what you can do is you can package it and deploy it somewhere automatically without you actually doing anything. You can just push it to GitHub and it will automatically do all the stuff for you. And the way that it works is when you upload it to GitHub and you push it to GitHub, the GitHub system will first it will do is look at the package JSON, right? It will look at the package JSON and it will say, okay, I have an application with name CLI. This is the version, and it will check, do I already have newer version deployed, for example? You know, it will act on the package JSON. The next thing it will decide, okay, I need to deploy it somewhere. Let's install the dependencies. So it will go through dependencies and install the dependencies. So basically, if you think about it, think about buildings, right? This is the blueprint of a building. This is everything you need to know about the building to build it up, right? So if you think about architecture and I give you a blueprint, everything, all the information in there you will have to actually make the build the house, right? So this is exactly what it is. It's a blueprint of an application.
But this is just for Node.js.
This is just for Node.js, yeah. You will find that other especially script languages, have something very similar, but package JSON and this format is for Node.js. Yeah.
Okay, thank you.
Any other questions? No? Right, so let's move on. I think we're gonna kind of skim through this. User input, that's what Ricardo was asking about. As I said, two ways to do it, either through arguments at the beginning of the program. If you want to make it during the program, you can use something as a, for example, this library, which is readline sync. This is your user making mistakes with the input. So readline sync, let's have a look at the documentation. Again, I know this might be boring, but it really is important. Just read the documentations before you start using something. So if we look at this package that is being recommended to use, you will see that, so synchronous readline for interactively running to have a conversation with the user via console. So basically what you're doing is you run your application and you tell the application, I want to get some kind of input from the user. And this is what kind of helps you doing that instead of you trying to implement it yourself. And there's a lot of documentation about it as well. If you look at this particular documentation is not great because there are big blocks of codes, and you kind of are expected to understand it. There's more in here, but yeah, every documentation has different shape. So let's install it. Readline sync. Right, so you have it in our project, and then you just ask the user for an input. Let's try if it works. So let's go back here. Run the program and say require. Readline sync. You can say readline, and I think it was question. And this is, I'm not gonna explain to you why do we do readline.question, because that's what you should be reading from the documentation. This is not my library, so I can't really explain to you why do we use it that way. This is literally from me going into their website and saying, okay, so what they do is they import it and then do readline.question. Right? So it's not something that I would know before actually doing this. It's something that you read from the documentation. Okay. And then you do console log. let's see if it works. See, so what's your name? Thomas. Hello, Thomas. So now, as I said before, what this library actually does, right? It might look very simple. Like, look, we wrote. I mean, if I remove all this formatting, we wrote 3 lines of code, and we can already ask questions during the runtime of the program, which is amazing, right? If you think about what it actually does on the background, the first thing that will kind of pop into your mind the more you write it, the first thing that pops into your mind is it stops the program, right? Like it actually, you see, the program is not exiting, the program is not ending, it waits for your response. Okay, so it waits for your response. The second thing that it does is it will let you write something, right? Which is again, it's not the trivial thing to do in the console. It will let you write something, and then when you confirm it with enter, it will read it and gives it back to the program that you're actually running. So there is a lot of actions that are happening. First, it stops the program from executing any further, and it waits for something. Second, it will listen to the keyboard and get all the input that you actually input into terminal. And third, it will take that input and gives it back to the script so it can do something with it. Now, all these 3 things are not one line of code. Some of them are more complex than others. So this is what libraries are good for. Instead of actually you trying to develop this, it will just give you the library to do it, right? And this sync, I suppose, in the name means that you don't have to worry about the asynchronousness of this. So, because normally, if you have program waiting for something, you would have to have callbacks or promises or something like that. This is just, you literally just write it on a line. So, you know, this program does a lot of stuff for you. I mean, this library. So that's what I'm saying. You know, understand what it's doing, but don't try to recreate it yourself, because it will be a lot of work. So this
can you actually, yeah. Can we, is there a way to go and see the code that is behind the read line?
Yes, so well, all the NPM packages are open source. So I mean, that's not necessarily true as well, but I would say 99% of the packages are open source. So if you look at the NPM, you can see, so just to read the website a little bit, you can see the name of the package, you can see the version. Those are very important things straight away. So make sure that you have the right package, make sure you have the right version. And then documentation on here, and then this column in here is very important as well. So what does that tell us? How to install it? Weekly downloads. It's quite important to know how popular something is as well, because you know you don't want to install a library that just like 2 people are using, because it could have a lot of issues. So if you usually go for the more popular ones. Again, version, license, if it matters to you or not, because for commercial products you need to make sure that you have the right license so you can actually redistribute the library. Size and all this kind of stuff, and then you have this homepage or repository. Homepage and repository can be different. In this case, they are the same, but if you look at the repository, it will actually take you to GitHub or any other kind of version control system, and you can see the code of the library. So you are free to explore everything inside of the library. First thing, package JSON. You can have a look at the package JSON, the blueprint of this, and you will see all the information about it. You will see if it has any dependencies or anything else, really. If you could, sorry?
I said right, yeah.
Yeah. If you look at so again, every library is going to have different kind of structure inside. So you just need to basically read the code and see how the connections are done there. But if you look at the library in this case, readline sync, this is the same name as the script, so I would expect that this is the kind of entry point to the application. And then you will see everything that it's doing. So we're not going to be reading it line by line, but look at all the work that this library is doing, right? I mean, all this stuff. Look.
Oh, wow.
1,329 codes. And there is more. So, and this is, okay, this is nice. So what I was telling you before, Node, oh, I closed my drawing, didn't I? So Node has some kind of set of APIs, and it will let you to do stuff, right? But there are some things in Node that you just can't do because Node didn't give you the functions to do it. So if you find something in Node that you cannot do, what you can do is call or execute another program, right? So if you look at the files in here, you will see a JavaScript, PS1, sh, and JavaScript, right? So these two files are not JavaScript, right? So that's already kind of makes you think this library is actually doing something that you cannot do in Node or in JavaScript, right? So what is this actually doing is, if you look at read sh and read ps1, that basically means sh is shell script and ps1 is probably PowerShell in Windows, so it supports both of them. And what this will do, and we can probably find it somewhere here. Yeah, you can see in here. So look, read line. This is the point of the script that actually waits for your input, right? And in Node, that is hard to do. So what this particular developer decided was that he will write a native script, a shell script in a Unix, and a PowerShell script in Windows. Oh yeah, you see PowerShell. So so it will write its own script in that, and then it will start it, right? So you can see in here, it will start the actual like a new process basically. So what it does on the background is you will start your own process, and when you're actually waiting for people to type something, on the background it will start a new process that actually takes care of the writing in the console. And once that's done, which is the enter command, once that's done, it will stop that process, and it will take the result of that process and feed it back into the application. I know it's quite complex, but you will eventually understand it. But at least you can see what the libraries will take care of for you. So, you know, this is what basically takes care of the actual input into the console. So you see, like, it's no easy stuff, right? Especially doing it synchronously as well. So this is actually very useful library. Yeah, they have some other examples in here and stuff like that. You can do some kind of range selector or something. Right? Yeah. Anyway, so you see how much logic it hit for you, and if you go back to the code, all we had to do was this, right? So that's amazing. Let's go back to what we're doing in here. Right, so now the user input. So what this library does is it will get the user input, but what it doesn't is anything after that. So if I say, what's your age in here, right, so if we do this, and I say Thomas, it will say you are Thomas old. Right? It doesn't validate that it's actually not number. So what this library will do is to get the user input, but anything else with whatever the input is up to you to do. Again, I think I mentioned this at the beginning. Whatever comes from the console is a free text, right? Which is a nightmare for the developer. If you have a free text anything, it's a nightmare to deal with, because you need to parse it somehow. You need to validate it somehow. People could use whatever they want in there. They could put space at the front or space at the end, and all this kind of stuff. It's always a nightmare to have a free text input. That's why on the websites with actual user interface, you can kind of mitigate that by using selectors or number fields or buttons and stuff like that. So, you know, you have more options in there, but in here, in the console, everything is free text. So there's always a lot of validation happening around that. So, for example, if I say in here, if I say if age is over 30, hey, So if we do this, and I say I am Thomas, then it will tell me that I'm young, because it doesn't understand the number. If I say, actually, as a matter of fact, if I say 31, because it's JavaScript, it will actually evaluate it as a number. But we can do console log. Just so you actually see. You see, it is actually a string, right? Just because it's JavaScript, it will actually evaluate it into a. This will actually work, but in other languages this wouldn't work. What is it going to do if we do 31 Thomas? Yeah, so 31 Thomas, it didn't understand anymore, right? So you need to basically validate your own input in here. That's the kind of point.
It was not a string, but it says it was a string. I didn't understand that.
Well, if the type of age is string, then it says it's a string, and otherwise it says it's not a string. And in this case,
when you put 31, it said it was a string.
Yes, because it is a string. Every input from console is always a string, even though it looks like a number. It's a string.
But then how did it recognize that the if function, like the age is more than 30, it says bang you all?
That's because this is 100% a feature of JavaScript. JavaScript will always try to kind of, be clever and see if it's actually a number or not. So in JavaScript, if you put just 31 in there, if you put just number in there, it will actually try that. If you say, age like this, 31, then what do you think is going to happen now? If I put 31 in here, what is going to be the output?
Well, it will be blimey, you're old.
Everybody agrees? Or not?
Yes.
Yeah? Yeah. And what if we do this? I'm actually not 100% sure.
It will say not a string.
Sorry?
It will not work there, no. It will say young, no?
Yeah. Because, as you remember, 3 equals, it will check the type as well. So we are actually checking number in here, right? But 2 equals will try to be smart, basically. We'll just check the value, but it wouldn't check the type.
Got it.
Okay, so here we have that. Well, so here if we are over 18, that's not true in here. Right, so this is basically what we went through, very trying to get it. So now the one way to actually handle the input would be, numerous parsing methods and stuff like that in JavaScript. So if we would actually want to say, if you actually want to get the number, so I'm going to show you this. So we would say we have the age, and then we want to get parsed age, which will be the actual number. Then we would say parse int. I'm not sure if you've seen that before, but basically it means take any value and try to get the integer, the number from it. And you would say, I want to parse the age. So now, if I check this, now it should tell me now it should tell me what? Now it should tell me that it's not a string, right? See? Because at this point we converted it into a number. Okay. So if we need numbers in our application, then we need to actually parse it. So there are a couple of steps in your application. So first step, sorry, let's just split this. So this is import dependencies. Here we have get users input. validate the input, and then in here would be basically do work, right? Do whatever you want with it. So these are kind of the basic steps of almost every application, right? So get some kind of input, be it from actually writing in the console or arguments, validate the input and do something with it, do some kind of work. Okay, so this is a structure of almost every single application. Do you understand how this is being, like, what's happening in here with the parsing and validating and everything? Yeah.
Yeah.
Cool. What else do we have in here? Well, we did that. All right. Now about the structure and names. I will read through this slides very quickly. So names are very important. This is the last step in what I was talking about at the beginning. It's very generic. It's not really just for Node applications. It's for any kind of piece of code, really. Naming your variables and functions is very important, because you will kind of bash yourself over the head if you come 6 months later into your application and try to do something and you didn't name everything correctly. You're gonna spend a week just trying to understand it again. So if you name everything correctly, if you put comments, and if you call everything the right names, then it should be more readable. Functions should be small. That's a good point. Don't try to get into something we call spaghetti code, where you just have like lots of lines of code for like unreusable stuff, basically. So functions should be kind of kept small and to the point, and there is more kind of principles that people try to follow. I would recommend you to read something about functional programming, where basically the idea is that every function has one input and one output, and it's always the same. And if you develop it that way, then you basically kind of getting rid of the surprises in your code, where you would think, okay, if I give some input to a function, then I can get 10 different outputs, and you just don't really know what is it going to output. And variable names should be descriptive. There is always kind of limit to this, but please do not worry to be to be descriptive about it. Parsed age. This is in no means a long name for a variable. This is perfectly fine. You will find variables that say something like this will go forward to server or something like that, and then you will have some kind of value. This is already getting longer, but it's still fine. Like, do not worry about being more descriptive with your variables. It's more about the readability, because then when you go, this is much better than just having a equals something, right? Because then you have absolutely no idea what this a is for. So yeah, don't worry about naming things longer, but try to avoid unnecessary things. So the kind of idea is, try to avoid like a proper language in your names. So if you say, for example, give me a beer, it will be a function, right? So you don't need this a. This a is just completely redundant. It's a good language, but you don't need it in the name of function. Just give me beer is fine, right? So these kind of things you try to avoid in the name of the functions. What else do we have here? So I think there's some examples. So this is example of a horrible names, right? So if you look at this code, you will be lost, right? You look at it, you have params that are I, J, K, then you have constants, which is GGG, the another one GGGG, and all this together is just very, very confusing, right? And then you get to this line and you have console log mn, and you have absolutely no idea what you're logging out, right? So this is exactly what it is about. If you and it's called do a thing. If you if you name everything correctly, then it's going to be so much easier for you to read it. I would say there will be someone at some point who will say, well, doesn't this impact a performance? And the simple answer is no, it doesn't, because at the end of the day, everything is compiled, everything is minimized most of the time, and it just won't impact your performance. It doesn't matter if you have the names longer or not. It's true that JavaScript, because it's a scripting language, you don't compile it into a kind of computer code, so the names will stay. So you could argue that the application will be bigger if you put longer names, but there are many tools, and there are almost 0 projects in JavaScript that wouldn't be using those tools that will actually minify this code for you, right? So when you look at your code that actually is a result of the compile that we do in JavaScript, usually you will have really nicely named functions. So you would have code like we had in here. Let me just revert this, right? So you would have this nice code in here where you understand every single line. And then when you look at it, when it actually goes through the compile, so after compile, it would be something, I'm not gonna even try to do it now, but like it would be something like R readline sync, because you can't really compile these. And then you have const b equals c, const d equals r, and then you would have something like pattern c d e, something like this, whatever. Something like this would be your code. All this code would be eventually compiled into this, right? Something like that. So you don't have to worry about the performance, even in JavaScript. Even though it's a scripting language which doesn't get compiled into a machine code, it's still, there are a lot of tools, and you will hear them. There is a Babel, there is a Webpack, there is other tools that will compile your code to this, and it will save as much space as it can. So do not worry about having longer names, but don't go crazy with it as well. But do not worry about it. So this is the bad example. You can make it slightly better with this. So you're calling the at least a little bit somehow better. But again, even in this example, there are some things that I would avoid. I would avoid probably naming them like this, and I would definitely avoid having a variable's name the same like your function. I would not do that, even though for JavaScript is not an issue, but you just need to be a little bit sensible about it. So this is already looking a little bit better. It's much more verbose, but you can understand what's going on in there. And then eventually you would want to split it into different functions, because there's no reason for you to have all this in one function. This is what I'm saying about the input and output. You would want a function that takes numbers and gives you some kind of magic number, not a function that takes numbers, creates a magic number, and then prints it out. Because eventually you might want to do something else with the number, or you might want to not print it out but send it to the server, or something like that. So you would split it into two functions. One would be to actually generate the number, and the other one would be to actually display it. And you can see the names of the function change as well, which is good, because before it was just magic number, which doesn't tell you much as well. Imagine calling this function in your code. You would be doing something like this. 1, 3, 1, 2, 3. Fair enough. It's better. It looks a little bit better, but you still don't really know what actually this function is doing. If you put the generate in front of it, then you know that, okay, if you see this in the code, you already know that something is wrong, because you should have something on this side, right? Because you know it's going to be generating something. So it's much more descriptive in that way. So that changed, and then the new function was created where you display the magic number. Again, very descriptive name. Doesn't matter that it's a little bit long. Doesn't matter. It just says display magic number. It's not necessarily the best name, because you say display magic number, and then you have parameter magic number. So you already know that you're displaying something, right? You don't need to repeat it. So this could be just display number, for example. But it's good enough, you know, like you at least you know what is going on. And then this is how would you use it. You would just say, this is basically what we did just then. You would generate the number, assign it in here, and display it in here. And this is how you get to a really nice and clean code. Because eventually, what would you do? Sorry, I don't have it in here. What would you do in here is you would take, why am I not moving? You would take these two functions and you would put them into a separate file, right? So you would put it to a completely separate file, and then in here you would just require that file. You would call these two functions, and you would display the result. And that's basically you creating a library for yourself, let's say, but internally in your application. It wouldn't be like a proper library. It's just kind of like we call it utility classes or something like that. So it's really, this is already getting into architecture of code, which is very, very important. But that's kind of comes with experience. Can you guess what this code does? I guess, well, yeah, what this code does. What is the thing? What is the E, and what does the display do?
I don't know the display function, but basically it takes each element of E and displays it, I guess.
Yeah, so actually it takes each element of thing rather than E and displays it. But anyway, you wouldn't know what the E is. You wouldn't know what the thing is, right? Like even then, like even though you don't necessarily need to know, it would be good to know. And you don't know how it's going to display. You don't know what it actually is going to do. So if you go further, what you can learn is for each means is an array, which is correct. So why not make it plural, right? Like it's things, not thing. And then you go through it and you get every element in there and you display it. Fair enough. But again, what is the E? You don't really know. So why don't you say that is a thing? So it's a thing from things, right? So you kind of make it a little bit more descriptive. So you send, because you need to remember that whatever is in here in those 3 lines, these 3 lines could easily become 50 lines if you have something very complex. So then when you go down 50 lines, you would not remember what E is, but you would remember what thing is, right?
Yeah.
And then if you put it into an example, let's say you have stations. So instead of things, you call it stations, and then you do for each in stations. You take every station and you display the station. So this is already much more readable, right? This is already something that you would easily read, and you would know, okay, I'm displaying something for every single station. Yeah. So comparing it to the first piece of code with the thing, I think this can you read it easily? Do you think?
Yeah.
Yeah. Everybody agrees. Everybody looks very tired. What does the display do then? Right, that's the last point. So this is already good enough, but we don't know what the display does. So this is what the display does. What we could do is display first letter. So actually in here you can see that it will display the first letter, but we didn't know that, right? Like if you use it in here, you wouldn't know that you will get actually only first letter from every station name. So renaming the function to display first letter will be good enough to actually just see that you display the first letter. So this is the final result, and it's much easier to know that, okay, I will display a first letter from every station in the stations. Well, this is to the code editor. This is our kind of structure. I think that's basically what we have in here. We could potentially, wrap these in the function, but this kind of comes with like more advanced examples. But I think as it is pretty good, to be honest. We don't really need this. Yeah. So this is our first you can already call this an application, right? This is our first Node CLI application where we take the age and we do something with it. We say you are old or you are young.
So can we use that for the project? Because
Yeah, do it. Right, readability, the most important factor when writing code. I would agree with that. I think readability goes above everything, because as you start working, you will realize that time is money, obviously, and if you have a piece of code that might not be that might not have the best architecture or might not be the most performant, if it's readable, you can always improve it. You can always save time, and you don't have to reinvest. The worst thing with readability that can happen is that you open a piece of code after some legacy code or something, and you're gonna be so lost or so confused that your first reaction will be, we need to rewrite this whole thing. And that's the worst thing for a business that can happen, right? So readability is very, very important. Coding is lots of reading. Literally wrote probably like 100 books in my life just with code. So yeah, that's what it is. Reading documentation, well, as I said, the most important thing. Every time I mentor juniors or something like that, this is the most important thing that I concentrate on, that they can actually read documentation. And if you work with me ever and you say, Thomas, how do I do this? My first response will be, did you read the docs? Because that's the most important thing. And it's not that I wouldn't want to help, but it's for your own good. If you know how to read documentation, you will not only save a lot of time, but you will become very valuable to every company, because you will find there will be always projects where they say, we want to implement with this system, how to do it. And you will know how to go read the documentations, figure out the requirements, and kind of take over, basically. Other people's code. Yes, reading other people's code is always a pain. There is no way around it. There are two reasons for it. One, because there's a lot of cowboys out there, and I say it in the nicest way possible. There is a lot of people who just refuse to write a good code. And the other reason is because every developer has his own opinion, every developer has his own style. You will never find a project where you would feel like, wow, like this is basically as I would write it. You will never find that. You will find better or worse projects, but what we do is a very kind of individual thing, and you just you will always struggle basically reading someone else's code. The best thing you can do is make it readable. Well, that's the last point. Make your code readable and make it understandable for others, because I can tell you, once you go through enough of pains reading other people's code, you will concentrate on it more, because you will think, I don't want other people complaining about me. And there is a lot of complaint. There's a lot of emotions when you read someone's code. So you will want to do that, and not only for other people, but for yourself as well. Many times I have been in a situation where I actually rejoined project, or where I was working for people that I used to work with or something like that, and then you look at your code from 2 years ago and you just want to kill yourself. It's just like make it really, like, kind of stop and make it readable. Personally, what I do when I write any kind of code, once it's done, I'll look back at it and read through it and see if I can actually understand it properly, and kind of refactor it. It sounds silly, but if you do have the kind of advantage of actually working in that kind of environment where you don't just have to spit out code like crazy, then definitely take a step back and read through it, because it will make a big difference in the long run. Any questions? I feel like I've been talking forever, so please give me something.
No, it's very good. The feedback, I would say, is like we learn what is behind our code, basically, like how it works, where it comes from. It's and how we should behave when we code, like for the other to read it nicely, so or for yourself not to make mistakes. So it's good. Yeah. Thanks.
Mm-hmm. Yes, I mean it's a bit. It's not necessarily about the console, about the CLI or anything, but anyway, it's a very important lesson anyway to make everything readable. I'm pretty sure that as you go through the exercise, you will learn a little bit more. You will get your hands on the console and on the CLI. Again, as with any program, any language, it can be as complex as you like. You can have very simple programs like we did just then. You just read one value and display it, or it can be an application that basically takes care of the world. Who knows? It can be as complex as you wish. Any other questions? We are running already a little bit over time, and I don't want to keep you too long. So just shoot if you have something. No.
No, thank you, Thomas.
Okay, cool.
Great lesson.
You're welcome. If you have any questions, ping me on Slack. The only thing I would say is, please, put my handle in there, because I tend not to watch the Slack too much, so so it actually pops up in my face. All right, thank you, and have a nice evening. Bye.
Thanks.
See you. Bye bye.